Hello, everybody. Thanks for joining us today. For this week's PAVE virtual panel, we will get started very shortly. Just going to give folks a couple seconds to enter in here from the waiting room. And as a reminder, you will be able to find the full recording of this panel and all of our past panels on our YouTube channel and our website at pavecampaign.org. So welcome everybody to PAVE's 130th virtual panel. Today we are going to be talking about simulation in the autonomous vehicle space with a special focus on Gatik Arena, a new simulation platform launched by autonomous trucking leader Gatik. And you might be wondering, hey, this is not who I signed up to hear from today. We are going to be hearing from Adam Campbell today, the head of safety innovations at Gatik. He is pinch hitting, but rest assured we will have a great session. So welcome, Adam. Thanks for joining us today.
No, thank you for having me, Caitlin, and welcome everybody on the PAVE community. And yeah, I'll do my best Gatik co-founder impression here for the next 30 minutes or so. Pleasure to be here.
Wonderful. So let's get started with sort of a background question. Gatik was founded in 2017. Can you give us some background on yourself and the company as well?
Sure. Yeah. Well, for myself, so I've been with Gatik now for just shy of 4 years, and so feels like a lifetime in many ways. There's been many accomplishments even in the last 4 years, but for myself as the role as of head of safety innovation, everything that's involved with concept design, testing, and implementation, and working very closely with our customer base is how I spend my days and how our team spends our days. But yeah, as far as Gatik is concerned. We've been on this journey since 2017, and if it's not that long ago, but in 2017, the autonomous vehicle industry was a very different time in a very different place. What was getting a lot of attention back then was, and still does, is the robotaxi applications and the big, the long haul tractor trailer applications of autonomy. And it was at that time and in that environment where the three co-founders of Gatik were looking at the opportunity for what was missing in the industry and what could provide real customer value in the near term, not just to go down the solving a technical problem for technology's sake, but really trying to understand true customer pain points, develop a product that customers want and need, and that the technology as it existed then and would trend to exist today can deliver on. And so as odd as it seems, we had a product first mentality here at Gatik and have developed a use case and a technology where we operate in the B2B short haul logistics space using a straight truck application of autonomy. And we've selected this segment of the supply chain to operate within because of the incredible value it brings to our customer bases. All our favorite retailers of the world that you know and love are feeling incredible pressure right now to deliver more goods more frequently and at lower cost to their end consumers, which are you and I. We're placing a lot of demand on those folks and those retailers on a daily basis. And so where Gatik thrives and shines is in supplying that high frequency of delivery, B2B on a known route, highly repeated route use case. And this has been the vision since 2017, and we're executing on it today. It's an incredibly exciting time in our journey. A lot of really exciting things to talk about, including Gatik Arena, but in the near term, we'll be sharing a lot of very exciting announcements as well.
Great. Yeah, absolutely. 2017 was around the time that I entered the autonomous vehicle space, and it has really changed a lot since then. So exciting times indeed. Now, switching gears a little bit, you recently launched Gatik Arena, the simulation platform that will really allow you to fine-tune your self-driving technology. Can you tell us about the new tool?
Yeah, so really big step back here. Simulation as a technology is incredibly important for the safety validations of any sort of highly complex software-based and hardware-based system. Autonomous vehicles there's no better example of that than with autonomous vehicles. And so simulation, what it allows for in broad terms from a validation standpoint is high repeatability, high control, and low cost of that exercise of safety validations. What we have done is we've expanded upon sort of what's available sort of off the shelf and created Gatik Arena, which is sort of a purpose-built, we call it end-to-end closed loop simulation system, which effectively allows us to deploy our software system in simulation, create data sets and manipulate data sets that we generate in the real world to develop, an infinite combinations of complex scenarios in which our vehicles will experience when deployed on public roads or could conceivably experience in the real world, and create these high fidelity physics-based models that allow us to narrow the gap to a sliver's width from what we are doing and evaluating the system in simulation to what we expect of that system when it's put into real world application on a real physical truck on physical roadways. So Arena is ours. It's our end-to-end tool chain. And we've also partnered with NVIDIA in the development of the World Foundation model application. So what that ultimately allows us to do is to take the data that we are generating in our environments and developing scenarios out of from the data we collect in the real world and effectively deploy those scenarios anywhere else in the world. The environments and scenes that we experience in Texas, for example, we can repurpose and deploy on the other side of the world by applying these World Foundation models that NVIDIA Cosmos supplies as part of the overall package. And so in the end, Gatik Arena allows us to expedite the safety validations that we need to execute on in deploying our vehicles on public roads without drivers behind the wheel. It allows us to provide ourselves even more confidence that we are testing in the long tail, and that sort of safety lingo, meaning to all those super rare cases that are highly likely to be experienced at some point in the driving lifetime of a system, you or I, or a technology. It allows us to evaluate the system, train the system, improve the system very quickly and at exponentially lower cost than having to try to do those same things in the real world. Real world testing is incredibly expensive in comparison. It takes much longer to do testing in comparison to what can be done in simulation. And ultimately, for our end consumer, it means that we can expand more quickly. We can ensure the highest bar of safety is maintained and improved all the time, and decrease costs ultimately for our operations when we pass that value on to our customers and on the commercial side of the house. And so this is pouring gasoline, if you will, on our scale and deployment programs here. We've already achieved quite substantive milestones in our driver operations to date with various customers that we've been very public about in the past, and is only going to further accelerate the path to scale in the future for us.
Fascinating. Sounds like an incredibly powerful tool and, of course, very important to the safety of it all, as you said. Now, you've mentioned this, but your business is really focused on the middle mile or sort of the mid stage of freight that's so critical for the supply chain. When it comes to simulation, what do you think are the biggest challenges unique to that middle mile space?
So, I mean, when we look, you have to think about, for any use case, you have to think about the types of exposures, like ultimately boiling down to the operational design domain. If you want to get technical for just a moment, unpacking what the middle mile is from an operational design domain perspective means we need to consider, holistically, sort of urban, semi-urban, and highway type environments and many roadway conditions, multiple types of roadway infrastructure, and roadway user interactions, right, of various types. We're not just isolated to highway environments where jaywalking pedestrians are highly unlikely, for example. We're not just looking at semi-urban environments where vulnerable roadway users, pedestrian cyclists are expected, and other types. We have to consider sort of a full picture, which means from a simulation perspective, that allows us to create and develop those scenarios, evaluate our systems against those scenarios in a much more expeditious way, while very much reducing the risk of sort of early introduction of very extreme sort of hazardous type scenarios in our validation testing. So from a middle mile perspective, from a use case perspective, simulation allows us to expedite testing again to things that are highly unlikely to be exposed to in the real world and are safety critical to understand the capability of your systems in, right? We have to evaluate our systems in those really difficult environments, understand the limits of the system, and ultimately what that translates into risk management and risk mitigation when deployed on public roads. But the opposite side of the picture is also important. It's not just challenges, it's opportunities. The middle mile and the way that we construct our network, we operate on known routes within a defined network that we scope with our customers. And so what ultimately that means is that we know at any given moment what the route will be of a given autonomous truck. on a day-to-day basis. And so when you start thinking about what is required to validate that route and that those systems capabilities along those routes and the exposures we expect, the sort of landscape of all things that are possible become in sort of the real world become very narrowed and very focused in comparison. So we can, in a sense, more directly evaluate the system's capabilities in the environments, in the simulated environments that we expect that system to be deployed within, and allows us to have good confidence coming out of the simulation-based phase of our validation activities that that system will perform as it does in simulation in the real world. So that gap, as I said before, the gap is much more narrowed, both because of the flexibility of Gatik Arena and how we can evaluate systems and scenarios and manipulate scenarios to include different types of interactions, but also because the use case allows for more direct application of that testing and validation activity. So the unknown space, it's always the unknown things that those who wear safety hats, are mostly are very much concerned about. That dimension gets narrowed exponentially because of the known route structure and the defined networks in which we deploy.
Really interesting. I want to take a step back here, and you've already touched on this a bit, but what kind of advantages do AI and simulation provide in testing that traditional real world on the road data collection doesn't?
Yeah, coming back to that point, public road testing and is risky, of course, right? Putting an experimental system on public roads is not the place you want to be starting, trying to understand your system. So that's why there's an upstream push to more evaluation work, more validation work to do in simulation. It's relatively low cost, faster, more controllable. You can adjust very nuanced elements within a simulation environment, like move the garbage can around a little bit, move that light post around, change the weather, as you want. You don't have to do a rain dance to try and get rain and to test in rain in the real world. You can, click a button and create, the scenarios in which rain, complicates, camera detection mechanisms and things of that nature. And so simulation allowing for that level of flexibility and to tune up and tune down complexity and ultimately map the landscape of testing that you were doing in a highly controlled fashion provides all of that opportunity for us. And so real world testing will never, I don't believe, will go away in the near or medium term. It will be required because ultimately, that is the deployment mechanism. The software has to go onto a real vehicle that has real mass and momentum behind it on roads that are imperfect with environmental conditions that are what they are in various places in the world. And so, to deploy and have confidence in the deployment in the real world, ultimately there is a real world validation element that is necessary. But the point is to get as much value of the upstream efforts in the simulation as possible to both expedite, decrease costs, which then is, it's from a business perspective is incredibly useful. And you start approaching positive unit economics and, really proving out the business case, the economic model of what we're doing. That's incredibly important. But so too is holding the highest bar of safety at the same time. And that is what I really get, excited about talking about with Gatik, is that it's not just one or the other. You can deliver safety and also do it effectively and efficiently. And that will allow us to not only deliver a viable product in the long term, not just to deliver one time, but deliver consistently and to save lives and improve safety on the roads and those that we share the roadways with.
Absolutely. When we speak with the public at PAVE, we get a lot of questions about sort of wild scenarios of, what if a truck of basketballs, went all over the highway, and that's hard to talk about with the public, but talking about options like simulation, for example, can help them sort of understand that you can test those edge cases, without having to go on the roadway. Um,
Yeah, and it's also about being able to generate those scenarios, not just about what we see in the real world being used to create, synthetic variants of those experiences in the real world. It's also about allowing for synthetic, truly fully synthetic data sets to be developed that challenge the system in unique ways. And the ability to do that is not trivial. You kind of have to know the exposure landscape first before you can find what was not exposed and then develop those scenarios and conditions and evaluate there, right? That mapping is essential. It's a challenge for any autonomous vehicle company to fully understand. But again, in our use case, when we were on the same routes over and over and over again, and deploying in such a reliable way, in a predictable way, that unknown, that's what I mean, that landscape of unknowns is much reduced because of how intimately we understand the environment in which we are deploying. And that's a far cry from other use cases of autonomy. And it's not to pick on robo taxis, but they have a much more and a broader autonomy problem to be solving for, not knowing where you're starting a route and ending your route sort of at the whims of who's beckoning that vehicle to show up and take them across town. Means that the validation, the end-to-end point validation of that system has to consider all possible, effectively infinite combinations of start and endpoints, in even a small area of a geofence region of a major city. And so, not to say it's an impossible challenge to solve for. I think there's good, examples of that in the real world today, that's being done effectively. But at what, cost and scale and requirements in order to execute in that type of environment it's expensive, and it's time consuming. We are solving that problem for the middle mile today. We are not looking to boil the ocean and solve all of autonomy's problems today. We are looking to deploy in the middle mile as reliably, as safely, as effectively as we can, and to provide that end value to our customers. Because ultimately, without their buy-in, without their understanding and commitment to what we're doing, this is cool technology that has no home. That is not Gatik's problem at all. We have the lineup is out the door for folks who are interested in the work that we're doing. We've signed long-term contracts with. We're really excited about the uptake of this technology, and the business offering and the value that we have seen committed by our customers. This isn't just us in a vacuum in a sort of phone booths, echo chamber of just a bunch of Gatik people saying that we love this thing. This is those who are outside of our four walls, who we've partnered with on the commercial side, who also see the value and are experiencing it on a daily basis.
That's fantastic. Um, Kind of on the converse of what we were talking about the last question, how do you ensure your simulation environments are really representative of the real world? Given the unpredictability of humans and humans' traffic behavior and road conditions, et cetera. Can you talk sort of about that?
So one of the major elements in that is, to ensure that the simulations themselves, and in particular, the ones that you create and change and manipulate from what you've observed in the real world, are still grounded in physics, the laws of physics, right? If your simulation doesn't have gravity or considerations of gravity and momentum and velocity and vectors and all these things, what the vehicle will be seeing and training against will not ever be representative of the real world, when real world objects are bound by the laws of gravity and physics and momentum and velocity. So we have to make sure that that is held in the simulation environment. And that's partly how, in the World Foundation models, partly where that is taking place. Static objects are static objects, things that shouldn't walk around and jump in the air like light posts and garbage cans don't and won't, unless intentional, to see what an edge case of a scenario like that might be. But that's sort of one of the bigger elements there. And then, for any dynamic elements, pedestrians, vehicles, and that, their motion parameters are grounded in physical laws, that we don't have vehicles accelerating and turning, in ways that only pedestrians can, and vice versa. And so things like that are required in order to have the highest of fidelity possible in the simulation, again, so that what you're seeing and evaluating your system against, and also training it against, are things that will translate into real world behavior. That's how the transferability of knowledge and findings between simulation and real world is very much predicated on that relationship. On the other side of it, though, perfection is also not always the goal in simulation. Sometimes what we want to do is make it less idealistic. And this is where Gatik Arena is incredibly powerful, is that, for example, from a sensor's perspective, right? Oftentimes what you see in simulation representations are sort of camera-based imagery, right? So it's you or I looking at our, you can go to our blog posts on Gatik.ai and see some of the ways in which we develop synthetic video representations of the real world based on what our system actually saw in the real world. And camera based and video based imagery for human eyes is easy to understand. I can understand a video, I can make sense of it in the way that our sort of software system does. But that we use other sensors as well. We use LiDAR, we use radar, we use other localization-based techniques as well. And so all of these systems combined aren't always perfect, right? We want to challenge the system. We want to, in the video frame, for example, it's not just 4K, high definition, clear without any obstruction. We want to throw challenges into the system's capability of using video. So we'll fuzz the video. We will throw raindrops, at the video frame so that it creates glare and distorted images, on the LiDAR side, which uses sort of laser scanning to create three-dimensional point cloud representations of the world. We will create highly reflective environments that make LiDAR-based imagery challenged. It'll create scatter. It'll limit the amount of returns back to the system. So we make it harder for the system. We challenge the system and train the system to operate in less than idealistic ways. So the perfect comparison, like there's sort of two ends of the same argument, right? Yes, we want things that are exact in the real world as they are in simulation, like the physics-based modeling and things of that nature. We also want to challenge the system to make it imperfect in simulation so that we can not only determine the limits of the system, we can also train the system to operate in a fail-safe manner, even when sensors and the information it's receiving is imperfect.
Really, really interesting. Now, how does the Arena platform integrate with your real world testing efforts? How do you blend sort of the virtual and the physical validation of your technology?
Yeah, I think we're not in a place yet to say all that, and and for not the foreseeable future to say that all system safety validation work will happen in simulation. I think that's a pipe dream, for many, many years ahead when even more sophisticated modeling takes place. But right now, what Gatik Arena allows us to do is to port even more of our validation activities into the simulation environment itself, therefore reducing the total time through the verification validation pipeline, as I said before, reducing the costs of doing so, and ultimately being able to maintain the highest bar and elevating the bar of safety along the way, because of the expanded envelope of coverage and system challenge testing that we can do and hazardous scenario evaluation that we can do very, very quickly with high repeatability and high control. That's just not possible to do effectively in the real world. That said, though, that doesn't mean that real world testing is unimportant. It is. It's like I said, this is a real software that is being loaded onto a real truck, that is going to be moving at speed on public roads. And so there is an endpoint, where the transfer of the testing activities does have to take place on the actual physical system in the physical environment, but reducing that dependency is and maintaining that high bar of safety and integrity is the sort of long-term goal.
Yeah, absolutely. Sounds like, the simulation component has been hugely valuable to
Mhm.
your testing and validation. Now, if we take a step back and look sort of at the bigger picture, this has been a particularly big year for autonomous trucking. How do you envision simulation shaping the future of autonomous freight and the industry as a whole?
Well, I think I can speak for us first. We what simulation is allowing us to do is to execute and to meet the demands of our customers in the near term. We've been incredibly successful in executing on driver out operations to date with multiple customers in the past, both in Canada and in the US. And what this is allowing us to do is to accelerate our deployment programming across the country. And so for the industry and those we share the roadways with, it means it's a massive unlock of scale. Being able to dependably, reliably deploy in multiple markets simultaneously with various platforms. This is the type of thing that simulation unlocks for us, and will ultimately translate into even further improved value for our customers who are, those that we are working together with on a daily basis to bring this product to the ultimate, consumer, which is us, you and I, who are, buying goods at our favorite retailers and all the pressures we place on them. So that's what I see for the future. I see more customer value. I see decreased costs. I see more expanded and scaled deployments across use cases. Gatik is not unique in the sense of using simulation in the autonomous trucking space in particular and other use cases. There is simulation that is being done, but for our sake and for the tailoring of Gatik Arena to our use case, you're going to see many more Gatik trucks operating on public roads here in the not too distant future.
Very exciting. Yeah, and I think you bring up some good points. I think the average American is maybe unaware of the demands that we all place on the supply chain when we're ordering from Amazon and Walmart and all these online
Supply
retailers. And
chain is one of those things no one knows about until it's broken. That's, those who work in the space know that very well. But we're happy to play our part in maintaining, supporting, growing the plans that our customers have to achieve their goals.
absolutely. So, just one more question for you, Adam, before we wrap up. What's ahead for Gatik? What are your goals as we look towards the end of the year and into 2026?
So yeah, we're, on an incredibly exciting path here. Like I said, I wish I could share more about where we are at today. I encourage you to keep a seat open for us in the next few weeks and months to come back and share a bunch of really exciting announcements with everybody. But it's an incredibly exciting time here at Gatik and in the industry at large. I think we're at the tipping point of a lot of really exciting moments that we'll look back on and in a decade and say like, this is when the world changed. We're right there, and like I said, it's an incredibly exciting time for the team. We're growing our teams. I encourage anybody who's on the other end of this call here, if you have what it takes to work in products like this, in our space, Gatik Arena and fleet operations, even we're more than happy to bring in the best and the brightest to help and to join along in this journey. It's a really, really exciting time, and looking forward to, like I said, even tomorrow, because every day is an exciting day here.
Definitely. Well, folks, you'll have to follow along Gatik on their website and social media to stay tuned for what's ahead. But thank you, Adam, so much for joining us today and on such late notice. Really interesting to hear about the great work that you're doing in this new simulation tool as well. As a reminder, we will post the full recording on YouTube and on our website later today. So be sure to follow us on social media at PAVE Campaign or check our website, pavecampaign.org, for all of the updates. So thank you, everybody who attended. We really appreciate your participation.
Thank you, everybody.